Let's take a look at the ransomware attack in Splunk. That is here, instant response, Splunk. Okay, so we talked about the defacement attack, where they downloaded an image and put it on the server, and the brute force attack they used to find the password to get on the server. But there's also a ransomware attack here, and that's down here. So first we're going to start by finding the IP address of this machine. This is what started it, I think, by plugging in an infected USB stick. So we want to find, that's kind of funny, the logs don't record the IP address of the components. That would be nice to add. And by the way, I should mention, if H.G. Moore wrote Metasploit, and then he quit and went to another company, and he wrote a new product called Run Zero, because he would do pen tests on a company and find an old machine and get in. And the next year he'd come back and find the same old machine and get in. He said, people don't even know what they have. So he developed a new product, which you should all get, called Run Zero.
I actually talked to those guys at that.
Yeah, and this product is just a superior scanner to find all the stuff on your network. Like Nmap, it will find all the devices and identify them, and you can do up to 100 devices for free, and that's nice. And I have students, my friends on Pulse Security Weekly, they say they're hitting the limit of 100 devices because their home has so much stuff. Smart thermostat, smart TV, smart refrigerator. I have like none of that stuff, but they have all that stuff. So this is a great product, Run Zero. And I just added it to one of my courses. I don't know where, it's a simple project. But you can run a free version, and everybody should be running it at their companies just so you know what you have. Because most companies do not actually know what they have. And that's a big problem. Anyway, so in particular, you don't even know the IP address of these things, and it's not trivial to find out from the logs. I was sort of surprised. That seems like such simple information you should have, but it's not that easy to find. So we'll start by searching for just that in all time. And we're finding 4,000, 6,000, thousands of events with that name on it. So something, traffic to or from that device. So we found 181,000 events. So now we'll find the sources of these events. If I go down here, here's the source. And so there are 5 possible sources. There are really 10, but the point is, I want to find the events that are used for Active Directory logins. And that is LDAP. Active Directory uses LDAP. So I'm not even going to let it finish. I just only want to look, see, most of them are other things. I just want the LDAP traffic that includes the name of that device. And there's only 74 of them. And now, I wanted to know on this particular day, 24 August 2016, here's a timeline. This is the 25th, this is the 10th. So I guess this is the one, yeah, from 7 a.m. 24 to 7 a.m. August 25, that's here. This is what I want. So if you want to restrict the timeline, you can do it by typing in times, but if you just click on this bar, that'll do it. So here's the events on just that day. Double click maybe? Yeah, double click. Okay. So there's 48 on that day. Now, look at their IP addresses. If I just look now at the destination IP, there it is, 192. So this is one end of all these events. They're all, that's the destination. Let me just go to my notes page. All right, this is the, that's one bit of information. And the other one is the source, which is here. And you can tell just sort of by common sense, typically the servers have low numbers like 20 and the clients have high numbers like 100. So this is the client and that's the Active Directory server. These LDAP events are going, this is the AD server, and the client one is that device named We something desktop. That's the desktop IP address. So now I know where it is. And this is beginning to analyze the ransomware event. So now that I've found that, now I want to look at Suricata signatures that developed Cerber ransomware. So Suricata is detecting suspicious traffic, and it did detect this because it's a known attack. So if I go here, I can search for Cerber. I'm going to go back to, I think it might be okay. I think it's okay to stay on this time range because the ransomware attack took place then. But I just want to look for Cerber here. How many events mention Cerber? And the answer is going to be thousands. Supposedly the answer will be 21,596. Okay, and therefore, it's okay that I limited it to that one day. The entire attack took place on that day. Okay, so I have 21,000 events talking about Cerber. Now I want the source field, I want the suricata ones. So again, look at the source. And here they are. See, there's thousands of them, but only 5 were from suricata. So I can just look at these. And now, I want to find the signature ID. So down here, here's the alert signature. So here it is, a check-in, error, onion domain lookup, and check-in. So this is the ransomware checking in. Here's the onion domain lookup, and here's error response. And let's, in fact, what's fun is to see these in a timeline. Here's the ID. All right, this is the flag, it's the ID that triggered the least number of times, but the signature is more interesting. So I'm going to make a table with this and time, and we can now see the timeline of the attack. You go pipe underscore time, comma, that field. And now we get, when it's ready, is it running? Church, I say. Oh, table, thank you, good. Good, thank you. There we go. And so now I can sort this by time, and there we have it. At 9:49, Cerber was run. Then, within a few seconds, it got a couple responses. Have a check in, whoops, and something bad just happened. I got to go back. All right, and maybe it's forward. There. And then, there, now let me sort it again, there. So here it is, this is the beginning of the ransomware attack, then it spent half an hour encrypting files, and it was done at 10:15, and it loaded the page. It did an onion domain lookup to pop up the page saying, your files are encrypted, you have to send Bitcoin to this address. So this is the exact timeline of the attack. This is when it started, this is the time where it did the encryption, and this is when the encryption was done. So that gives us a lot of useful information about analyzing this. All right, so now we can find what was the domain name where it went to at the end of its encryption phase to load the ransom node. And so, let's see, suricata, onion domain lookup. Right, so here, in order to find the domain name, I need to find DNS within 1 second of the onion domain lookup. So down here is where it's going to show me the domain. And the easiest way to do this is to use the GUI. Before, I was actually typing in the time, and the worst thing about that is I'm often in the wrong time zone, so I'm off by hours. That's why I learned to not do it that way anymore. The way to do it is find this and click on the time. And now you can narrow to this time range. And you can specify, this is the time range between 10:15, 12, 6, this is within just a few milliseconds. Now I would like to narrow it a little differently. Let's see if I can, there's some way to make the time range plus or minus 1 second. I figured out how to do it before. How about view? I don't want that range. Let me go back. If I can figure out how to go back here. All right, looks like it opened a new tab. All right, so here. Before, I have figured this out. I think if I get rid of the table, that might help. I found before there was a way to click on the time and then narrow yourself to within, there, this is the time. If you click on it here, there we are. Now you can make it plus or minus 1 second. See, there's so many DNS requests, you don't want to have any wide time range. This is how you accurately get very close to that time. There we are. Now I've got these 2 events, and now I can look at DNS events in this time period. Stream DNS. So I want to change the source to stream DNS. And it's not going to say Cerber anymore. They're all the DNS traffic on the network in this 2-second time period, and that's 15 events. And so I can go down here and I can find the DNS query. And there you are. So there's harmless ones. This is the malicious one. Cerber random junk dot this junk. This is the domain lookup that loaded the ransomware page. These are innocent ones. And so that's one way to get there without going nuts. Because even a minute of DNS is way too many events. All right. And so what's the first suspicious domain visited by this website? And we can find the suricata events on that day. and then the source IP field. So anyway, you can find the websites it's been to. You can find the actual script that ran. Let's try this one. This one is fun. It's VBS and EXE. So if I go here, it's probably the last thing I'll show you now, I think, but let's do VBS and .exe in the same event. And I better expand this time range to all time. All right, otherwise we'll look within only 2 seconds, and that's not going to do it. Okay, there's only 16 of these, and there, examine the body field. All right, and here is a this is all normal stuff. There, this is a malicious script. You can see the funny writing. This one is malicious, the third one in this list. So I'm just going to make, let's just do what I did before, make a table. Pipe, table, pipe time, and body. There. All right. And a new process has been created. That's normal. This is normal. This one has the malicious script. You can see the script that's going to do the malware encryption. This is the ransomware itself. And you can read it, and you can see the structure. You can tell they've obfuscated it. Here's where it's going to use a random name of VBS for the name of the script, and then it's going to run it. And then it calls this, and it has functions, GNIB, PQ, and all that jazz. It names all the variable stupid things. This is the mess that searches for all files and encrypts them. And that's what ran for half an hour, encrypting a whole bunch of files, and then popped up the ransom note. And you can find the information about the script. You can find the USB key that was plugged in to start all this. You can find the file server that it connected to encrypt the files on the server. And you can find how many files of different types were encrypted. The PDF, you can watch the encryption happen, and the process ID, and so on. So that's why people pay for Splunk. You can do this kind of investigation, and this gives you practice in finding the simple things.
So when you describe one of the group of texts, funny language or funny text,
Yeah,
so
obfuscated. Yeah, this is just to make.
just seeing the script, the encryption.
No, obfuscation is not as strong as encryption. Encryption is where you really can't get in without the key. Obfuscation is where you just make things hard to read. You just make them hard to read, like Pig Latin, base 64, like this. Instead of using a reasonable variable name, you give everything stupid names, and often you create a function by, like, you make a variable with like 100 letters, and then you add the letters together, like letter 17, letter 50 to make a command, just to make it hard to read. It's very commonly done for web attacks, like PHP attacks and JavaScript attacks. They just make it hard to read. Just so people, the original plan was just so people wouldn't steal your JavaScript. But malware people do it all the time. And so, like I say, when I have this kind of thing, the easiest thing to do is find their decryptor and run it. But there's also online deobfuscators that will just convert it back to more readable text. Yeah. This is not encrypted, it's just hard to read. That's obfuscation. But that can slow you down. Yeah. Good. All right, let me stop this video.